Hey everyone, Dr. Tom McNamara back again for our course in trigonometry. We're going to continue talking about graphs of trig functions. In the last video we discussed the factors in the function's formula that would change the amplitude and period for the graphs of sine and cosine. If you look back at that video, you'll notice we never actually dealt with any negative numbers. There was never a negative multiplier out front, nor did we have any negative multipliers inside. So we'll talk about the effect of negative numbers here in this video. So let's do a quick example here. I'm just going to pull one out of the textbook that we're using. Graph one complete cycle of y equals -3 sine x. Okay, so you'll notice my multiplier there is a -3. Now, you might be tempted to say, well, that means the amplitude is -3. Okay, that's not quite true. The amplitude is always positive, because that's telling you the maximum distance from the midline that you're going to go. Okay, so the amplitude is 3, period, 2 pi. No multiplier on the inside, so our period remains 2 pi. 1, 2, 3, 4. So I'm dividing up my length of 2 pi into 4 equal segments. 1, 2, 3. 1, 2, 3. All right, so that's coming from this amplitude. Remember, amplitude is always positive. Okay, now let me tell you how the negative affects this graph. Okay, so I give you an input value, you take the sine, multiply it by -3. So your y value is going to be 3 times what it used to be for the same x value, and it's going to be negative. Okay, well, the positive y values are up here, the negative y values are down here. Okay, in fact, I'm going to draw just the regular sine curve right here. I'm going to make a little ghost of the regular sine curve, little dashed line. Okay, so just so we can compare the two and see what's going on. Okay, so when x equals 0, the sine function is giving me 0, so my y coordinate is 0. Now when x equals pi over 2, if I take the sine of pi over 2 radians, I get 1, which is what this graph is telling me. 1/2 goes in, 1 comes out. That's what it means for 1/2 comma 1 to be on the graph. Hit that with a -3. So your y coordinate is -3. 0, +3, back to 0. Okay, once again connected with a nice smooth curve, and there's our graph. Okay, so the blue, that was the original sine function. The one in the white, that is the graph of y equals -3 sine x. Okay, so it's reflected across the x-axis. It's upside down of what it normally was. Typically we're going up at the beginning, here we're going down. And of course the 3 is telling us we go down a distance of 3 units before coming back. All right, so a negative number out front is going to reflect the graph vertically across the x-axis. All right, I want to do 1 or 2 more examples here. Let's try this one. It'll have a couple negatives in here. Okay. Actually, I guess we don't really need to worry about what happens if we put negatives on the inside, because we've already talked about that, but I'll show you one anyway. Okay, how about this? We'll do, give me one with a pi in it. Y equals graph one complete cycle y equals, how about we do this? -2 times cosine of, and let me put a negative in here. -2 pi x. Okay. Now, before we get started here, we're going to say, okay, we know how to deal with the negative out there. It's going to flip the graph vertically. Amplitude is going to be 2, and that negative will flip us over. What about this negative in here? Well, look back to our video on even and odd trig functions. So make a little note right here. Okay, we know that cosine of negative theta for any angle theta is equal to cosine theta. Okay, having a negative on the inside of the cosine function doesn't really do anything. Cosine is an even function. Now, if I was dealing with the sine function, it's a different story. Negative on the inside, well, you take that negative out. Okay, so I can replace this part, cosine -2 pi x, that's the same as cosine 2 pi x. All right, the -2 just comes along for the ride. Okay, so we can combine what we know from the even odd functions to help us deal with negatives on the inside. Any negative on the inside, you either get rid of if you're dealing with the cosine function, or you pull out if you're dealing with the other functions. Sine and tangent are both odd functions. Okay, so to get to my graph, I'll look at my amplitude, I'll look at my period. Amplitude is 2. Remember, amplitude is always positive. Okay, you never have a negative amplitude. Period, 2 pi over 2 pi. Period is 1. All right, so 1, 2, 3, 4. That's my complete cycle divided into 4 pieces like always. If one complete cycle is 1 unit, and I divide that into 4 pieces, each piece is 1/4 of a unit. 1, 2, 1, 2. Amplitude 2 means I'm going to be going a maximum distance of 2 from my midline. Okay, now ordinarily cosine starts up here, goes to the midline, down, to the bottom, back to the middle, and then up. There's a negative out front. That means the whole thing is flipped vertically. So I start here, at the bottom, to the midline, up top, back to the midline, and then down here. Connect these guys with our nice smooth curve, and we got our graph. Okay, so negative on the outside flips your graph vertically. Negative on the inside, use the properties of even and odd functions to bring that out or get rid of it. If you got a negative on the inside of cosine, nothing happens. If you got a negative on the inside of sine, pull that negative out, and now you're back to familiar territory. Okay, so we've got a complete little playbook here on how to graph functions, how to graph sine and cosine when there are changes to the amplitude, when there are changes to the period, and when we have negatives outside giving us that vertical reflection.